Hey guys, welcome back. In this video, I'm gonna discuss about the Codeforces contest problems. Basically, if you have attended the education Codeforces around 165, I was able to solve only first two of them. Remaining, I tried to analyze and learn the concept. So in this video, I will discuss how we can solve the third problem and the fourth problem. And in this video, basically, I will cover the third problem. In the next video, I will cover the fourth problem. So, in the third problem, they just said that you are given an integer array of length n and you can perform the following operation. Choose an element of the array and replace it with any of its neighboring values. And for example, a is given as 3, 1, and 2, and then you can replace with any of its neighboring values. Basically, this 1 can be replaced with 3, like 332, or this one can be replaced with 2, 322, like that. And we need to find the minimum possible total sum of the array if you can perform the operation at most k times. Like one operation we can replace only one a number with its neighboring values. Basically, let's say we have an array like this: 10, 19, 2, 4, 20, 43, like that. And we can replace this value with its neighboring values, and with neighboring value at most k times. In one operation you can replace only one number, and we can use it at most k times. At most in the sense k or less than k, and we need to get the minimum possible total sum of the array. Like in first iteration, what will you do? You will either replace 19 with 2, or you will replace 20 with 4. There are you will try to do it like that. Like, if you replace 19 with 2, what is the cost of doing it? Like you are cutting down the 19 and adding 2, which means in the sense it is minus 17 in this, right? Total, let's say you are getting the total sum that is in the variable sum, and you are replacing this 19 with 2. Then we are subtracting the 17 from the sum. If you are replacing 20 with 4, then you are subtracting only 16 from the sum, right? Minus 20 plus 4, 16 from the sum. So this is subtracting 17, this is subtracting 16. So 17 is greater than 16, right? So basically the best possible option is replacing 19 with 2 rather than replacing 20 with 4. Like that, we can say it manually, but we need to do it programmatically. So that's how we are able to do. Now for the elements which are present in the middle, they have two neighbors, left and right. But for the elements which are present in the corners, they have only one neighbors. For the leftmost element, they have neighbor which is right of it. For the rightmost element, they have neighbor which is left of it. And the one more important thing is that if in one operation, if you're changing it, let's say, for example, in the first operation, what will you do? Replace 19 with 2, right? Uh, I don't think this will be a good array example to explain what I'm coming to say. Let's say we are having an array of values like 312, 3 comma 1 comma 2. What will you do in the first operation? You will replace 3 with 1, right? 3 with 1. Let not 3 2 1, 3 2 1. Okay, let it be 3 2 1, or 331, 331. Yeah, this will be good. Let's say let's say if the k is 2, in the k is 2, in the first operation, what will you do? Replace this middle 3 with 1. So if you replace middle 3 with 1, what will the array will become? It will become like this, right? 3 1 1. And in the next operation, what will you do? You will replace this 3 with this neighboring element. Note that this neighboring element has been modified. You need to replace this 3 with the modified neighboring value, not with this the old neighboring value. Like, understood, right? As soon as the values are modified, that will become your current array, and you need to proceed the changes from that. So next iteration it will become 111, and then you will stop and you will get the sum, and then you will print it. That's how it goes. So how will I proceeding? They are giving the test case t, and in the next line you will get an n and k, where n is the size of the array and k is the number of times the operations can be performed, and in the third line you will get this thing, now values of the array. So basically, as I said in the previous videos as well, if we are finding the word like minimum, maximum, or total number of ways, those keywords 80 to 90% are pointing towards dp, which means that you need to use dp in your this thing. It can be either be 2D or 3D dp, but you need to use dp. That's what I am going to say. So for any dp problem you can solve it. Don't just try to directly write the tabulation approach that is done by expert people. If you are very much new beginners, no, don't try to directly write the tabulation approach. It will take a very long time and you will make a lot of mistakes in that. So first write the recursion approach, next go for memoization, and then do the tabulation approach. Basically I solved it also using, just by writing the recursion I got and wasn't able to pass few of the test cases, and then I memoized it and then it was passing. So just by writing the memorization approach without writing the tabulation approach, it was good to go. So basically I will explain how to solve this problem. So you can have a vector which is collecting the n and k to collect the n and k values, and vector to collect all the values, and dp, where no, I'll just come to this thing. This DP, it is used for memorization. We will just basically discuss the recursion approach in the basic, the first case. My recursion function has four parameters. One is v, n, 0, and k. V represents the original array, which I am collecting it from the user, and n represents the size of the array, and 0, as you can see here as well, it will be in detail, and 0 represents the starting index, where I'm from starting the array from, which is I. I'm starting from the 0. Initially I'm calling that, and k is the number of operation, that is the utmost number of operation. So what is the base condition of an array? If the I current index, if it is greater than or equal to the size of the array, it has no point of running the recursion, right? No point of running the recursion, in the sense we can just return it 0. Don't see this part. This is done for memorization, and I'm assigning a variable answer for a long max, and then minimum value I'm keeping it as initial index, basically v of I, or when it goes for next call, it will shift to the next one. So basically you just need to run a for loop where from all the k iteration, beginning from the I, like for each I you need to run the for loop for all the k iteration. Like if the, but in that itself few useless conditions will come. If I, the current index plus the kth iteration value becomes greater than or equal to n, then it has no use, then I can just skip it. I can just come out of the loop, and if it is less than, then I can happily proceed inside it and collect the minimum value from the previous minimum I kept it as v of I. Now the previous either this value can be less, or v of I plus the kth iteration, that value can be less. So either of that I will be taking it, and then I will be proceeding to the next recursion call. Yeah, now basically try to get the keyword from the question. If it is minimum, you need to use the minimum everywhere in the question, in the recursion call, as well as calculating the answers. But if it is called as maximum, like finding the maximum array, you just need to replace variable I used minimum, then you need to use the maximum. And w- now comes the memorization, which is very easy step. You just need to see which parameter in my recursion calls are changing. V is not changing, I mean array is remaining the same, and n is also not changing, size of the array is also same. Only thing that is changing is the my starting index position. I mean I don't need to call starting index position, and then the k. the number of at most operations I need to perform. That those two are changing. So create 2D array with that sizes, one with I and one with k. I mean the size is one with n, one with k. So you can use the resize stl operation, or you can also use, there is another function called memset function in C++, that is also can be used for creating a 2D array. And or else you can use a vector of vector also. After using it, after creating the 2D array, you just need to initialize the all the values in the 2D array with the -1. If the particular value in the 2D array is -1, if it is -1, then you need to proceed calculating the answer. Why? Because it doesn't have the memory of already experienced recursion stuff. So if it is not -1, just return the what you have, like, basically you will be having recursion stack, like this parent recursion will be calling child recursion 1, and recursion 2, and this child recursion 1 will be calling another subchild subchild recursion with the recursion 3, and then recursion 4. So basically what happens is, when solving the recursion 4 and solving the recursion 3, you will be getting the values for recursion 1, and after getting the values of recursion 1, you will be going to the next child of parent recursion, which is recursion 2, which will be calling another two sub child recursion, which can be in, in in most probable case it will be repetitive stuff, like recursion 4 and recursion 5. It need not be repetitive, but it can be repetitive. If it is repetitive, why we need to again do the recursion 4 if you have already done it? If I already done it, just store the values in this 2D array, and yeah, like it's like storing the memory, or storing your experience of the recursion answer. If it is not equal to -1, which means I have already experienced that recursion, return that value. If not, just store it in a 2D array. In future it will be of useful. So that's how you can solve the third problem. I'll attach the solution link in the description. You can go through it, and I hope you understood what I tried to explain. And if you have found any other way of approaching this problem, please mention it in the comment section. I'll also go through, and it will also helpful for me to gain my knowledge. Thanks.